Good evening. We're Spyropoulos Studio, the WaveScape team. My name is Daria. This is Gip, Pavel, and Jean. Our studio explores the elemental aspect of natural phenomena as technology resources. In the thesis, we studied the wave phenomena in the context of formational technology. Sound wave can be examined as immaterial substance that cannot be seen or touched, but that permeates everywhere. In the initial theoretical studies, we focused on the physics aspect of wave phenomena, understanding its nature. Our research states that all elements in our environment are impacted by frequency forces, as our universe is vibrational energy. We aim to explore ways of controlling environment by implementing wave structural principles. These are our first digital experiments. Understanding Chladni-Figas patterns formation, we consider wave to be the force that can influence the particle-based environments, merging immaterial and material fields. You can see the structure of our research process. We started with the basic frequency experiments with various materials, tested how different environment conditions influence the particle formation, then tested the possibilities of controlling systems, which led us to the implementation of wave phenomena as formational technology. Human interaction and exploration of first-person experience through augmented reality tools allowed us to extend the concept of the new architectural paradigm. Material experiments with the vibration panels above the speaker introduce the power of the wave force. You can see how frequency force influence the tiny little water droplets. So observing this process, we realized that at the level of 360 Hertz, the water droplets become fixed and we can clearly see the energy pattern. Frequency vibration affects the motion of a particle depending on the material properties. Experiment with solid sand particles showed that at equal frequencies, the distribution of material varies according to the particle size, separating the grains of sand. Experiments with water and cornstarch illustrate the behavior of non-Newtonian fluids, which has characteristic intermediate between liquid and solid. Frequency actuates the fluid to change its states and aggregate into masses by increasing the coherence forces between the molecules. Physical experiments with various materials under the influence of wave force showed that frequencies had affected the motion of particles in relation to the property of materials. We discovered the possibilities of creating the desired state in the surrounding environment by effectively controlling frequency force.
Then we were interested in the effect of frequency on the particles in closed environment. We tested different boundary conditions as a control external parameters for the particle-based system. Other frequency experiments can be conceptually divided into three boundary conditions, such as one-dimensional, two-dimensional, and three-dimensional ones. You can see on this slide how the particle's behavior differs according to the change of frequency within the single two boundaries. We were able to observe standing wave phenomenon due to the oppositely direct sound sources. We intend to control particles by turning on and off two speakers. Moreover, not only a force from sound wave, but also a static force from each particles and plastic tube influences the formation. Then we start thinking about ultrasonic wave exploration. In the following prototypes, we aim to achieve more precise three-dimensional control over particles' movement in the open environment. The first prototype allowed us to levitate a single foam particles using two ultrasonic sensors. Ultrasonic sensors produce the same standing wave phenomena as we previously observed in the tube. The overlap of ultrasound waves creates a nodes and anti-node zones of different air pressure, making a particle levitate. We designed the ultrasonic phase array board to achieve the three-dimensional control over particles' movement. These are the components we use for creating two ultrasonic boards. The main elements can be divided into three categories, such as PCB boards, transducers, and programming the processor. You can see the assembling process of the ultrasonic phase array board. We started with preparing PCB board. Then we baked the majority of the components to the board and then soldering the rest. The next step was the programming of a GPA and calibrate of ultrasonic transducers.
Starting our machine with one board experiment, we controlling the position and number of focal points, we observed ultrasonic wave force influence the behavior of materials. We extend our experiment by incorporating ultrasonic phase array. This array can be controlled to create single or multiple focal points. The overlapping ultrasonic phase generates multiple node layers, forming an invisible ultrasonic field. This field is observable to an array of levitated particles in the physical prototype. Then we test it with multiple focal points to see the possibility of the machine by creating different side grids. This experiment shows that the more focal points there are, the less stable particle control. We also experiment with liquid materials. Here are an oil drop in two focal point arrays. We can hold and move oil drop without losing their shape. Then we change the underneath surface to water, which affect the behavior of wave interference. We can see the wave effect on the water surface. As the surrounding environment becomes fluid, we understand how the powerful wave force impact the surface. We can see the particles stay and move more stable. We try out various solid. We try out various solid particles in our experiment. We see that the way they behave is influenced by both material property and the particle size. Here we test it with salt, styrofoam particles, and cornstarch. Then moving on to two ultrasonic board experiment. With two boards, it's around more precise three-dimensional control over particles movement. In three-dimensional acoustic manipulation, the dynamic movement of styrofoam particle is made by precisely adjusting the position value of the focal points to an acoustic simulation programs. As we can see in the left diagrams, the shade of blue colors are the amplitude of the wave interference, and the different color at the top and bottom show each phase generated by the transducer according to the software generator. Then throughout the different phases, we can levitate and move these particles three-dimensionally. In the experiment, we created 4 focal points by adjusting the phase of ultrasonic wave. The software turned the focal point into a phase array. Here you can see a levitating water droplet. We observe stable three-dimensional control particles of different matters. Liquid particles, such as water droplet, show dynamic behavior influenced by external forces. This video shows the focal points array when the water particle explodes. We can successfully control the levitation of water droplet in different axes within the wave nodes. This experiment involves manipulating 2 focal points to combine and separate particles. It highlights the potential of merging ultrasonic focal points to enhance particle manipulation, which contribute to our understanding of large-scale application in particle control. We try to capture water molecules from the fog with different number of ultrasonic boards. This video shows the droplet capture from a single board. The concept involves utilizing a fog, a substance easily filled with volumes. By applying ultrasonic wave, it transforms the fog into multiple water droplets. Then we apply 2 boards to achieve more three-dimensional controls. This fog can be condensed into water droplets within the desired focal point. The objective of the experiment is to achieve manipulating of this water droplet. This methodology shows the capacity of capture and control water in its molecular forms, enhancing its ability to control matter within various environments.
And moving on to continuous formation. In previous physical experiments, we used the wave frequency as a force to transform and control the particles, and start to think about how we apply this particle control logic to the spatial volume. In this initial design experiment, we applied wave phenomenon as an agent system to control the particle-based environment. In this simulation, white particles are passive elements that consist of the environment responding to the wave forces generated by the red agent. From the previous particle control experiment with the levitation machine, we extended our idea to the spatial formation system through wave forces. The wave system is working on the ceiling of the spatial unit, and we classify 4 types of system behavior according to differences in wave phase changes. This formation catalog is showing the wave interference of different units. Each 10 by 10 meters unit consists of 40,000 particles. Depending on the unit type, they have 4 to 8 wave generation points. And also, we are interested how the overlap of waves affect the behavior of the particles. We combine the same and other unit types for understanding influence of their condition on the overall particle behaviors. These simulations are the combination type of same system behavior. In the interaction area, we can manipulate more diverse particle behavior and create many iterations for the use case. The simulation of invisible forces help us understand spatial formation logic. Based on the physical principles, we define the formational system driven by wave phenomena.
Starting with the research of explicit natural phenomenon, we applied its formational technology on the competition side of the Center of Pompidou, maintaining the boundary of the existing building. We consider the Center Pompidou to be the architecture of a mechanical paradigm. Its innovative approach of using the building as a platform for various social activities redefined architectural norms and exhibited advances in engineering and construction, making it a symbol of the architecture and technological process of the time. In the new architectural paradigm, we seek to develop the particle-based architectural system that can be rearranged and reconstructed on various scales. We are creating an environment where the subdivision strategy are based on wave formational principles. This prototype was made to lead an experiment with landscape continuous formation. We used proximity sensors connected to cooling fans. As soon as the particle interacted with the sensors, the fans were actuated and influenced the landscape. This experiment began the development of the closed-loop systems and the continuous landscape formation. In our proposal, all technical parts and entrances group are located underground, so we unite the different levels of the site with common landscape and make the building transparent as possible. The main part of the building is a ceiling made of panels with transducers emitting ultrasonic waves. Also, fog is sprayed from the floor and ceiling through fogging nozzles. This diagram illustrates our ceiling system, which contains an array of ultrasonic transducers emitting ultrasonic waves in the contained volume. When two waves interfere to each other, they create a focal point array, causing continued formations of particles. We develop our floor system to detect and interact with crowd behavior. You can see on the top diagram, each individual creates a small light gradient. When they gather, the floor will detect them as a group, then triggers a ceiling to create a specific space according to the crowd movement. The flow slab is designed to integrate various levels of the piazza into a unified landscape. At the same time, the design helps water drainage, allows the slope to a centralized collection point, considering the accommodation of underground services. Then we began to connect our surface with the particle system based on the result we explored in the formational catalogs. Zooming in the development system, we prototype a section of it, 10 by 10 meter. The gradient of the powder printed models illustrates the positions of the focal points.
Moving on to the experiential architecture part. Understanding interaction between human and environment through phenomena was the aim of these initial human-scale experiments. We redefine a new concept of architecture that breaks away from the existing architectural framework and allows for organic interaction with humans. In this system, individual human behaviors are classified at local level and interact with particles within the boundary of the individual activities. There are clear differences between how individual and group behaviors influences system behaviors. Global level interactions directly affect the whole spatial formation of particle-based system. It detects users through a lighting system built into the floor and convert them into humans' location data. The floor uses lighting system to guide and detect human behaviors, and the system interacts by manipulating the particles' density and speed according to human behaviors. We use augmented reality as a methodology to test this new particle-based environment. We consider this particle-based environment as an archive for accessing information beyond the physical space. AR easily overlays digital information onto the physical environment. From this technology, the system can integrate digital information with the physical particle, and it allows users to access data information within this new architectural system. The combination of particle-based environment and augmented reality allows us to interact more actively with the system. In this experiment, users can react to particles within the detected distance by changing color and interact with selected particles. The AR device is kind of interface in this system. Users can directly interact with the system with this AR interface. In this manner, users can recognize physical particles by converting them into data assets and access the types of information that building contains through the interface.
The research of explicit natural phenomena led us to the development of technology that can operate within a broad spectrum of materials and scales, as WaveForce doesn't recognize any difference between solid and liquid particles, expanding the possibility of interaction and spatial experience. The system subdivision strategies correspond to the materiality of the studied particle. Water droplet and create a natural atmosphere based on the elemental aspect. The ultrasound waves capture water molecules from the fog and arrest them in the grid lines. The developed water retaining system allows the loop circulation, recreating the natural cycles in the building system. The thesis explores experiential architecture by pulling virtual involvement into reality through the implementation of wave phenomena. Based on our previous experiments with augmented reality tools, we aim to create a new concept of a museum archive that expands the possibility of our consumption. We see particle as a piece of tangible media that triggers a way to access data information by physical interacting with it. With user, that unlock immersive experience, creating a symbiotic relationship between the tangible and digital. In this project, we push the physical boundaries of architecture by creating a data archive system. The research aims to develop a new concept of architectural center, the Museum of 22nd Century. We develop a particle-based architectural system through wave phenomena, addressing a new wave of information consumption, which can exist without the physicality of the exhibiting objects. We see the potential of acoustic levitation technology, as the developed system can be anywhere. It has no specific side boundaries. The implemented technology gives a wide program range, allowing the design of continuously changing event spaces according to the contemporary needs. Time, duration, and speed are essential parameters in our project. We aim to integrate visitors in a dialogue with the created environment. Users' active behavior influenced particles, making them denser and more stable, so people can communicate and with continuously changing space through spatial interaction with particles. We expect our research on the wave phenomena to open the possibility for future exploration in the context of the new architectural paradigm. You can also scan the QR codes, which are on the slide and also on the boards, to get the first-person experience of some of our VR versions of the project. Thank you for your attention. I'll also introduce our models. So the first one is the spherical boundary environment that we tested. You can also see them on the boards. And the next one is the tube environment, where we were able to observe the standing wave phenomena. These are the setups for all our material experiments with different frequencies. This is the first prototype with the ultrasonic exploration. This is the levitation machine with the two phased array boards. So this is our archetype of the one of our formations that represents the global interaction within our system. So here you can see the people gathering in the center, and the system responds to that behavior, creating the space for the interaction. These are the printed powder prototype of our formations. The gradient on the model represents the position of the focal points that influence the formation. And on the next raising 3D printer models, you can also see how the positions of the forces influence the behavior. And this is a prototype of the closed loop system. The interaction of particles with the proximity sensors creates a continuous formation of the landscape. And we can also demonstrate the levitation of a particle in our levitation machine. Thank you.
At first, I thought the particle was slightly twitching from the applause, actually. It was quite... Yeah, I just want to congratulate you on a really remarkable and incredible project. I mean, the first quarter of the project in particular was frankly breathtaking. I need to understand so that I could be appropriately effusive, the sort of like level of existing science essentially around these techniques. Obviously cymatics, like the Hans Jenny stuff, has been around since the 60s or something like this. I'm curious, like this particular kind of technique using the ultrasonic transducers to create levitation, is that something that's is that something that's known science, material science, or is this something? To what extent are you guys sort of like drawing on existing literature around this technique? Because it's amazing. I mean, it's just absolutely magical.
Now, the technique of ultrasonic levitation is now widely used, and especially also in medicine. And this particular prototype we designed based on the research paper where we can see its potential.
Yeah, I mean, it's I mean, I've never seen it in an architectural context, and the possibilities are quite, I think, quite marvelous. I mean, a couple of things I was kind of curious about. I mean, you've extended the notion of cymatics to a volumetric, into a volumetric space. And one of the amazing sort of revealing things about cymatics are these sort of two-dimensional patterns that give you a sense of the structure of what's happening sonically. I was curious the extent to which you looked at sort of like similar sort of volumetric studies, because those would be, I think, really revealing actually in terms of the kinds of hidden spaces that are emerging here. And then there's also a field which you may be familiar with, which is very closely related, called wave field synthesis. And wave field synthesis basically creates soundscapes using arrayed speakers within a space, usually within a plane, but presumably also in a volume. And there's a way in which this could create space, but could also be a kind of like highly multisensory experience as you move through the space, experiencing those different aspects of sound. So, yeah. So, and then I guess the last question is, if you're using a set of ultrasonic transducers, I was wondering, as people are walking through the space, why they are not levitating or being crushed by those ultrasonic waves. Anyways, those are a couple of questions actually that I had.
As it is still exploring technology, people for sure won't be levitating in the building, but there will be some limits in the implementation in the real world, which should be explored furthermore. And we, in our particular project, we were mostly focusing on the elemental part of it, so how this can be as a formational technology, and we experienced it through the series of physical experiments and also through some digital studies that helped us a lot to form our final picture of the thesis.
I just mentioned briefly also the idea of atomizing data and having this as sort of like an archive for data, because it's very interesting. There was a media installation which I saw several years ago, which basically used small foam balls, which were similar but coated with a sort of luminous fluorescent coating, where if you directed a laser toward it, it would illuminate. And so essentially you could make this entire thing a sort of screen with that kind of remote activation, which, at least in that installation, was a very, very beautiful, mesmerizing effect. But anyway, very cool work.
Yeah, I can just follow up on I think we were all mesmerized by how the misuse of science into architecture and what the creation of space and spatial qualities is just really stunning. I think it's really impressive research, so congratulations to you all and to Theo for the agenda. I think this is really impressive. I'm dying to be able to go into one of these spaces and really experience them, even if I get wet, or something. But I think the main question would be, I would have just love to see the next level of scalability of this, right? How much material can you move if it's not water, if it's solid, how can you levitate, and then really create these transformative and adaptive immersive spaces into a more real interaction with humans, with actual material that is not just either water or these 1 millimeter spheres, right? I think that is the only question. I think because the science at this scale and that scale works stunningly, but I think for this to be able for us to experience it, I think could be good to understand if you even tested scaling this up and to what level the science fails, or the possibilities of this, because it could be endless if it does become real, right? But congratulations, really, really impressive work.
I mean, even within this matrix, was there a limit why, was there a natural limit on the number of balls that you could levitate in this matrix, or yeah, or the size? Yeah, exactly.
Is there? I'm also interested in the scale of this proposition. Yeah, I mean, I'm sure we all are quite mesmerized, as was said already about this. But I find it also something that obviously on one level is quite magic, that it has a sort of physical potential for translation of it into actual physical balls rather than, let's say, coded space of light or some kind of, let's say, representational condition of it, because I kind of understand the other one is representational in the way that you code the digital AR, augmented reality with etc. So in some ways, this is like it moves into a whole different space. And the wonder of it is that, in fact, or one of the wonders of it is that, let's say, the Centre Pompidou, which is trying to give it a scale, whether that scale is actually something that you consider for real, dimensionally, or whether it was just the notion of its kind of being a part of the heritage of Centre Pompidou's generations of innovation in space. What was your reason, or was it dimensional, the relationship to Centre Pompidou?
The Centre Pompidou was an important project for us because it was a revolutionary project in the mechanical architectural paradigm, and as we try to see our the technology of acoustic levitation as a possibly new architectural paradigm, that's why it was important for us the site conditions. Yes, this is, for example, on the archetype, you can see this is the literal plan dimensions of the Centre Pompidou comparing, yeah, on the plan, not the height of the Centre Pompidou.
No, but my question is whether this scale, it would work, because that's how you did it in that one, right?
Yeah.
Yeah, it is a one-to-one scalability, right? Yeah.
Dimensional spread of the actual one-to-one. Does it?
Yes.
Following on that, perhaps, because I had a similar question, first of all, was to say that it's extremely interesting as an architectural experiment. And I think that's what you open up here, and I think this is commentable. But following on what you asked, Oma, if you are wondering if it's real, and that's kind of, I want to ask what is digital and what is material and what is tangible and what is visual and what is material. I mean, that these boundaries were not very clear, at least to me, or how we see it, how we start perceiving it, not only as an experiment, but also as a potential environment. And because if I understood well, you were explaining at the beginning how we can start considering perceiving or designing or creating space as an outcome of human behaviors or human activities or events. And that's a very fascinating idea, but I don't understand, it's not yet, and perhaps that could be the next step, how that translates into real, I don't know if real is the right term here, environment. And the scale, the more I hear, the more I see, it seems to me that all scales are interrelated, interchangeable, because you move from the molecular to the environmental at once. So, which is also kind of pushing the boundaries of space making or architecture, even on that level, which is kind of the stronghold of the discipline, right?
Fantastic project, and well deserved at this final prominent position of discussing amazing work. So I want to contribute a little bit to the conversation. So I think there's architectural merit in exploring this, even if it can't be realized physically on that scale. I would argue, because once it's a diagrammatic potential of an animate, responsive, but also proactive, curating events and social interactions in a space, and we can then afterwards ask, how are we translating these? There might be multiple ways of translating this diagram. If the ultrasound wouldn't reach that scale, or if it was becoming, you know, a health issue, etc. But I think it is an inherently merit in this kind of wonderful using these systems, and if, for instance, this kind of cymatic patterns, three-dimensionalized. What is interesting about them that there's, which is in this condition, you have one kind of finite set of particles, and they're moving from one to another formation, and to some extent there's a morphing trajectory, and they kind of lead from one to the other. And I think also, and I've mentioned that before, these studies can also be wonderfully used for generating virtual spaces. And since I'm very interested in metaverse, there could be a metaverse version of this. One way of translating this in the most literal sense, and you're doing that through the augmented reality condition. Now, what I think where this should have and could have been developed further is by more homing in on the social choreography that it could facilitate and make happen when you're organizing a large crowd into an interesting, intricate, multi-stage condition where also it might break apart in multiple groups and then come together. Here's the moment when the opening speech is happening, and then there's different sub-series, let's say in a museum context, to make this truly instrumental and making that experience. So that's why I think, where's the exhibits, what is the program of the scenarios this sustains, and there could be many, of course, it's such hugely malleable, but to show to us how this could be. I mean, this is one instant, but that's why I think, and that is the power for me, and we would need that in the metaverse, for instance, where we actually freed from a lot of this, but to then having that freedom, because we can do everything, but then doing something particular with this lovely, this degree of porosity, the density, the alignments, the transformation from one to the other, which makes it to a degree predictable. These things don't pop out of nowhere. And that's, I think, very, very powerful. I love also the difference with the water, where I would translate this way, say the water is where you can add particles. And then so in this, the polystyrene would be, say, where it remains finite, which has as a constraint interesting predictability conditions, and when you can add additional, but maybe the fork, you see it and you know more is coming, etc., etc. So I think that's for me the real project, and you can work on it without having, as of yet, certainly would be fantastic to physicalize them all for it. And you showed balloons, and you showed also wind activating. So there are many other ways which wouldn't be precisely these lovely standing waves and cymatic patterns. There would be other similar conditions. And this idea of swarm architecture and porous, unleashed and highly transformative architecture. We've been trying this for many years, and when we say swarms of furniture, they become nearly particles from part to particle formations, articulating spaces. These were literally discussions for 25 years, and when particle swarms became available, we've been doing them. This becomes more of a physicalized condition. It's very powerful, but I think to make this a programmatic scenario based, where this is not the spectral but the framing of the interaction and other elements, the speech or the workshop or of explaining a piece of artwork to a group of a certain size and intimate. These are the what we're looking for, and this becomes a kind of framing and subsidiary, the instrumentalized for these conditions. That's why I think I see the project as fantastically stimulating, and your expertise of running these animations and getting the inspiration to the physics. There's all sorts of, all art particle animations are kind of physics inspired, but then you can bring them also out of range. But what they all share is it's not a random drawing a figure out of them. There's a kind of logic and coherence of transformation and modulation, which we can grasp and which I think could be instrumentalized beautifully for these. And that's why I think this idea of having information embedded in these balls, I haven't subscribed to the critics last time, because also when you click on a ball, how do you know what you're looking for? This seems to be a random generation of an information. So this part of the story, I think, is a bit of also stepping away from architecture as framing and generating and defining social situation, but now in a very fluid and transformative way. And I think that's where the project is truly remarkable and inspiring. And yeah, I think we're gonna, I'm sure the metaverse will be the first instantiation, but that's not the last. It's only.
Fantastic. You've heard quite a lot. So I'll see if I can add to it. All week we've been talking a lot about the nature of research. And the question is, whether this has a kind of productive, pragmatic application. And actually you have a number of projects here. Or whether this is serving as a metaphor. I mean, the delight that we have when this thing starts to leap and dance is because you've created a project that's alive. It has its own organism. And it's responsive. And there's something surprising and wonderful and, again, playful that you don't often see in a project with this much rigor and work behind it. There's something wonderful, and I think that's why we keep asking whether it's real, whether it's scalable. There's also this component of turning one material form to another, the fog to the water droplets. And for a moment, I thought we were going to have another water harvesting situation. But I'm kind of glad your colleagues have done that beautifully. And then this last iteration with the archive, I find fascinating, but it's a very different project. And it's where you start to bring the Pompidou Center in, which was this kind of radical idea of a kind of an open exhibition space. And at the moment, there's a question of how do you contain knowledge, how do you contain history, how do you contain culture? And that it might have the possibility of being playful, interactive, being alive, is perhaps only at the moment metaphorically a really beautiful way of describing something something extraordinary within extraordinary terms. So I think it's something at the moment that doesn't need to combine and reconcile and become all of the projects brought into one. I think there's 2 or 3, if not 4 projects here. I think they should maintain a degree of separation, of layering and the kind of complexity, but really well done and mysterious and playful. Really fantastic.
I wanted just to say that maybe, I don't know, people, you might be, it's a younger generation than the one when Centre Pompidou did the exhibition of immaterials. Do you remember it? Actually, they had a very kind of interesting beginning of how the force of, electromagnetic forces became kind of active. And perhaps that was at the level of the metaphor, perhaps not quite, because in fact they did use physical particles that magnetically produce forms and reshaped, etc. So in some ways I find this is kind of a very interesting promise of this moment when materiality crosses over, and it is not only a metaphorical operation, actually. In fact, it is trying to mix the AR and the responsive potential of the particle, or even the magic kind of hovering one, to become something that engages. So you can translate it into light waves or humidity intensities or layers of formations of humidity, humidity making space or layers of space. I find these very, very, they are amazingly promising. And also, not just, I want to emphasize that it is not metaphorical, in fact.
It's either or, though. I don't think it has to be metaphorical.
Huh?
You wouldn't have metaphor.
But
yeah.
I don't think metaphorical necessarily means not real. I don't think they're incompatible.
Okay, no, but there is a step that I find that you have actually been able to cross, which has made certain behavior of these particles, which are physical, subject to a certain behavior, which is responsive to whatever waves that they're using, magnetic, or in this case, ultrasound, etc. And so that to me is the way in which you have now kind of, I think Centre Pompidou might be very interested in your project as a kind of continuation of this interest in the immaterial, the role of the immaterial in the way that we behave, not only behave to get it responsive, but how it is already there, and we are now kind of registering it in its potential representation. So really, congratulations in many ways. It totally beyond me to think how you do it, advance it, but it's really a very beautiful experiment. I wondered if this object that you created was something that you got going in the actual wave formations, or was it something that you speculated on?
So this is this model is based on our digital experiments, digital formational step, when the people gather and the building response to that behavior and create. I don't know if we can see it here. So yeah, this is not randomly placed particles. This is just a literal physical. How to say, physical visualization of our digital experiment.
Okay, because it's almost that time. Viviana, please.
Now, just a quick one. I really like your project. There is so much research and so much, magical, as it was said before, but also real potential in this project. One comment, or maybe one thing to think about it after DRL, is looking again at this human versus control environment condition, and try to step it a level up when it comes to how the spaces will be reacting to the physical movement or congregation of people. Few people have mentioned this, and I think there is so much that from this system you can still learn and you can still look at, that it would be a pity if you don't continue in this. So thank you very much.
Thank you.
Okay, I'm just going to make a kind of concluding comment because I think you deserve it. This place has a lot of stories. People talk about narrative. This place has a lot of ghosts and a lot of conversations about things that have happened and things that haven't. And I remember one of the reasons that I came here was really not because I knew anything that happened here, but I recognized the fact that there were people that I really found very curious, thought that their work was very different, and I didn't understand it. And one of the purposes of coming to the AA was, in some sense, to find a space where that understanding for myself would actually manifest. There are a lot of kind of stories about REM and others and these kind of fantastic diploma projects and all of this other kind of stuff. I think your presentation and your project today, especially the first third of it, is radical, it's provoking, it's bringing physics and science and architecture and all of these kinds of traditional ideas of conventions between the digital and the analog, program, function, really into some form of crisis, and I think it's amazing. And I think it's amazing because we have this kind of feeling that somehow those things matter. They matter to the architecture that we speak to today, of course. But I don't think that the nature of design research is just to kind of reinforce the orthodoxies of what we have today. And so to bring this as a conclusion, I think the project is experimental, it's youthful, it's optimistic, it's curious, and it's not making any claims outside of itself, which I also think designing a PC board, doing all the kinds of crazy stuff that you guys have entertained me with for the last 16 months is a testimony to the fact that you were curious. You had no guarantee that any of this stuff would work, but that's the whole point about being a student, and that's probably the only value that this place actually has. You can't teach architecture. but you can at least be part of a journey. So with that, and because Thomas is here, and we're going to have a conversation about different journeys, and we got to transition this space to make it as inclusive and accessible to probably 200 people that are standing outside as well. I want to bring today to a conclusion. I want to thank the critics for engaging us in 2 days of conversation. It's not an easy thing to discuss the stuff here, and as you can tell, we are all obsessive, lost souls into this whole kind of foray of architecture and what it can be. So I think, like, you know, for the students, congratulations. I don't think this stuff should sit here. I know that people talk about research, talk about practice, talk about getting a job and all that other fun stuff. You guys work really well together. And that, I think that's the other thing. The shared experience is something that I think you should continue. So for the students here and for everybody, we thank you for joining us on these 2 days. For the people that are joining online, I'm going to ask something that maybe is not even humanly possible. Here's where physical things matter. I'm going to ask for everybody to leave the lecture hall so that we can actually put some chairs so everybody can come back and attend this keynote lecture that we have with great anticipation for you. All right, thanks so much for today.